This is SciByte, episode 50 for June 12th, 2012. Hi everyone, you're listening to SciByte, Jupiter Broadcasting's weekly science podcast that comes out every Wednesday morning over at jupiterbroadcasting.com. My name is Chris, and joining us every single week is our host, Heather. Hey there, Heather.
Hey there, Chris.
Hey, Heather. Happy science to you.
Happy science.
What are we talking about this week?
This week, we're going to take a look at estimating dinosaur weight, pollution data, exoplanets, mosquitoes, the Johnson Space Center, Io, updates on Venus transit and neutrinos, spacecraft updates, and as always, take a tee back into history and up in the sky this week.
Wow, packed episode. We got a big doc we're going to plow through tonight. And
right on through it.
And, you know, we're going to invade a little dinosaur privacy when we go look at the dino weights. Nothing is sacred, folks. It's our first news story. All right, tell me about the dinos and how we know that they're a bunch of fatties now.
Oh, poor dinos. No.
Oh, okay. It's not like that?
No.
Okay.
So yeah, we've talked about it before, you know, all these kind of, you look back at all these bones and you're trying to figure out how the muscles are fitting on there, what kind of weight they have based on, you know, the bones. But it's all been kind of hand-waving stuff. Now they've got a new way to estimate it. I mean, in the past, they've done everything from, one of the ways they used to do it was having the skeleton and have like an artist like make a little clay model based on sort of what it would be, and like take the volume of that and guesstimate, okay, this is going to be the weight of this animal.
Right,
so,
right.
All kind of very hand-wavy.
Yeah.
You know, some of it less hand-wavy, but what they've done now is they've gone through a whole bunch of modern-day mammals like reindeer, polar bears, giraffes, elephants. They've gone through and they've measured, lasers, but with the bones, to the amount of skin wrapped around those skeletons.
Okay.
So it's like how far from the bone to the outside of the limb. And it is, every time, it was pretty much exactly 21% more body mass than the minimal skeleton skin and bone volume wrap. Okay. So what they're doing is they're taking the bones, and then they can extrapolate from that, say, okay, the skin is this far away from the bone. And so basing it off all those other mammals, because they were all pretty much the same.
Yeah, I'm following that part. Okay. So we're using the animals we do have good data on to kind of extrapolate, well, if they had this, then the dinosaurs might have this as well.
Yeah. So the previous estimates of the giant brachiosaur, it's the big dinosaur, the long neck.
Yeah.
Those kind of varied anywhere from, estimates as high as 80 tons. But applying this new approach, it jumps down to just 23 tons.
Ooh, it's quite the diet.
Yeah, quite the diet that these guys are going on. So it does require, it requires a minimal amount of interventions. I mean, there's no, you don't have to wait for an artist to draw it up. You pretty much just have the skeleton, plug it in, and it spits out, the size of the dinosaur. Now, it does mean you have to have a great majority of the skeleton. Because you really need to know what the skeleton looks like and sort of just to estimate how far out the skin and the muscles go.
Right.
But, in general, the estimates of dinosaur weights have been falling since the early 60s. So, we make guesstimates of these giant lumbering beasts. And as the decades have gone on, we realize that, no, they were a little better diet than that. Nope, a little better diet than that. Nope. They keep getting slimmer.
They're getting less and less cool in a way. Because I always picture dinosaurs as these ginormous monsters, but
they're still ginormous.
Yeah, okay.
Over 20 tons.
That's now, but when we're doing SciByte next year, you're going to come over here and we're going to sit down. You're going to say, you know what? Look, there's these dinosaurs here, Chris. By the way, it turns out even smaller than we thought before. And every year, Heather, you're going to chip away at these dinosaurs.
They're not going to be that.
Okay.
They're not going to end up like some Halloween little skeleton creatures.
No, we know that's not the case, right? Because we have their massive skeletal remains. And,
Now, it may jump back up just a little, because none of the creatures they did the estimates on reindeer, polar bears, all those kind of things, they don't have the massive tails that the dinosaurs do.
Okay.
Yeah, that's more like, alligators, crocodiles.
Yeah.
So that's kind of their next step is they're going to go to those kind of creatures and laser calibrate off of them. So kind of get a better idea of the overall system. Maybe the tail and the hind legs, have to be bulked up a whole bunch, in order to do that, because that's how it is in the long-tailed creatures.
How ridiculous do you suppose it is that, I mean, if they could go back and they can go get the skeletal structures of these dinosaurs, how ridiculous of a possibility would it be for the dinosaurs where, they don't have a great skeletal picture? I'm thinking of like the one we talked about, I think it was just last week, where they kind of made some assumptions in a few spots, like in the neck particularly. Couldn't they do something like that in some sort of computer model and then sort of say, assuming that the skeletal structure is essentially like this, which it would kind of need to be for everything to fit together, we can kind of guesstimate its overall size based on these new parameters. They don't have to have the whole thing, right?
Well, no, you can guesstimate and also say, it's, the dinosaurs related to it. So it's like the cousin to this species dinosaur is kind of laid out like this. Now this has just a little bit of a different bone structure.
Yeah.
It has this kind of a frill on its head versus that kind of a frill. But you can kind of get an idea of what the skeleton's going to look like. You can estimate the hip size, the femur size, those kind of things. You can say, okay, well, this is the estimate now based off these new results. So it's all that kind of cyclical thing where you have a basic system that can estimate these type of things. So you estimate, the skin and the weight. And then from there you can go in and say, okay, well, if there's this much room for muscle, then this is how the muscles were probably laid out. This is how the tendons had to be. You can kind of work from one part to another.
Right.
And you can say, okay, this is this, the most complete skeletons we have, this is how they are. Now, these other kind of dinosaurs are similar here or similar there, and then kind of use that to fill in the blanks, to get an estimate.
Right.
So it's, those photos where, there may be a chunk missing.
Yeah.
Now, if it's of a tree and you have a different kind of a tree, they're similar, you can kind of, plug it in and it doesn't look too bad. If you have a rose bush and you're trying to stick in daisies, not quite as much. So you have to find similar things to kind of fill in the hole.
Yeah.
To give you a better estimate of what the complete picture shows.
Very interesting, and I guess it's to be expected as our techniques get better that we will, sort of refine previous findings that we kind of thought were pretty dead on.
Yeah. Well, I mean, they start this. If you look at the early sketches of how they put the skeletons together, it's kind of funny and weird. And for the longest time, they all had the dragging tails. The tails were just kind of dragging along behind the body, and then they kind of figured, oh wait, nope, they're all pretty much swinging straight out. So there's a lot of steps that these things go through. That go, okay, this is how they are set up. Now we estimate these kind of things based off this data. So as we get better, as you said, if we get better ways to do these, then we can get better ideas of what was actually there.
Most certainly. Well, interesting. And another great dinosaur update. We always seem to find some really... Heather, you have an eye on the dinosaur scene, don't you?
Yes. Well, I was to space as one of my brothers was to dinosaurs.
Yeah.
So
I went through a bit of a dinosaur phase as a kid, and I kind of grew out of it, but I had a friend that also stayed in it, and so I kind of know what you mean. Yeah.
Well, a lot of those things, like you go through it as a kid. You go through the space, the dinosaurs, the dirt.
In fact, my boy Dylan right now is huge into dinosaurs, but he's huge into everything. But the Land Before Time, things like that.
Well,
any other thoughts on that story?
No, we'll just keep an eye out into the past and the future that studies the past.
Yeah. All right. Well then, let's pause here just for a brief moment, and I have a great announcement. Made it on the Linux Action Show this week, and then our first episode of Coder Radio shipped this Tuesday morning. So if you are interested in software development, like myself, I'm very much a beginner. If you are interested in more of the more, I would say, advanced category things like the actual business behind running your own software development company, maybe being a contract developer, getting jobs and things like that. There's all kinds of interesting angles we're going to take on the show. Our first episode covered beginner tools, gateways to programming, things to get you started, some of the things to consider, and also what you kind of need to keep in mind if you ever want to be featured or show up in an app store. So go check out Coder Radio over at Jupiter Broadcasting. It's a brand new show. It just launched. We're very excited. And there you go.
Awesome.
Yeah, and that's hosted by Michael Dominic and then co-hosted by myself, a new guy on the network who at some point we got to get people to like meet people and say hi to each other and stuff. That way people know who each other are and whatnot. You know what I'm saying?
The giant Jupiter Broadcasting roundtable.
Right. I think of it as like, see, exactly. You got Jupiter Broadcasting as the planet, and then each show is like a moon orbiting Jupiter Broadcasting with its, with its own unique characteristics. All right, Heather. Yeah. Well, then why don't we move right on to the News Bite? Now, one of the things that I think a lot of people remember from the Olympics was the pollution issue in Beijing. So I see you have a Chinese pollution data story here, so I'm kind of curious about this.
Yep. Well, China has come out and said that foreign embassies are going to be, that it is illegal for them to issue their own quality air ratings, that only the Chinese government can release anything about the pollution levels.
I don't like the way that sounds, to be honest with you.
Yeah, they decided it's related to the public interest, and so that is only allowed to be used on the government. So they have their own ways of measuring it. Now, it's the quality from China, they've said it's, good. And all the embassies from the U.S. say, wow, off the chart, bad. So it's interesting in the fact that the U.S. Embassy was actually sending out these data on Twitter, a Twitter account, and it was so followed in China that they were actually like getting their data from that instead. And so they went up to the government and they're like, okay, something's really funny here. You say B, they say F minus minus.
Wow. Is that kind of a difference, huh?
Yeah, well, on that scale, not specifically. But so they based it depended on the size of the particles. So they said only 10 micrometers or larger. Now they're kind of saying, okay, now we're going to change the way we measure it. So it'll include the smaller particles. So, and that, other countries say that is the majority of the pollution. So they're changing their ways about how they're going to measure it and send it out. But they're still going to stick by the line of only they, could get it, that the U.S. Embassy could do it, but for only U.S. citizens. And that's kind of what the embassy said, is that we're producing our data for our own people. Did
the Chinese government, they said for public interest, did they say what that interest was? Because that doesn't seem like public interest to me.
Yeah, this is definitely a story that was kind of a bit of politics in this science.
It does seem like it. It seems like maybe there is a little bit of, hey, look at China, look at them. A little bit like, now they're not necessarily true, but isn't it convenient to paint them as really bad polluters because it kind of lets sort of I know, but it lets sort of our own guilt about it off the hook a little bit because we're like, well, we need to clean up our act, but China's real bad.
Well, I was more taking a look at it as that China says it's the public interest because
they don't want them to know how bad it really is.
Yeah, they decide that they're going to dictate to the people everything about everything. And so there's kind of I feel like they've got a little bit of pressure to up the science a little bit to kind of make it a little bit better, a little bit more accurate.
Yeah,
so that maybe
I fear that
the
it's
people
more
can
about,
see that.
I fear it's more about controlling the message, and
trying to controlling the message to the people.
Yeah, because they do have a serious pollution problem, and they do get a bad rap for it, and they want to clean that. They want to clean that up.
Yeah.
And
so it's direct. They want to control the message going in and going out.
Yeah.
But anywhere where there's a bit of a change in policy to kind of increase the accuracy of scientific data, I like that.
Yeah.
Or whatever view you have on it, or the China or the Chinese government or pollution, that increasing, the accuracy of something.
And I'm sure the Chinese government will be working closely with the U.S. Embassy to verify that their data matches up, so that way they can, have a third-party validation. Oh, no?
No.
No.
I stayed on the science side of this issue, but even peeking over the fence to politics, I don't think so. I think the politics are sad in that, Chris. I think you made politics sad.
I know. You're right. Yeah, boy. Thank goodness we don't have to do politic bites. Ooh, politics do bite.
No.
Actually, that might be
as close as I wanted to get. But
politic bites. So it might be a good show. It's a good name, at least. All right. Well, should we talk about some exoplanet imposters?
Yes.
What is this?
So we've talked about the Kepler Space Telescope before. It measures, keeping an eye on a chunk of the sky. It sees the brightness level of stars going up and down.
Oh, yeah.
And that's measuring the planets. But what a new study suggests is that as much as 1 in 3 of those may not really be a planet if it's a giant planet opening close to a star. So we've got, out of the, over 2,000 planets, say 46 of them are categorized as large exoplanets orbiting close to their star.
Mm-hmm.
Now, 11 of those have already, were already known. The team confirmed 9 more. Now, what of left means you have 13 unknown things, 2 brown dwarfs, 11 members of binary stars. So they started really analyzing this because it was looking in there saying, okay, you know what? Giant planets orbiting really close to a star are still really strange. Everything, the data that we have, based on everything that's coming in says that's kind of an outlier. So what they started doing is they started looking more closely at those. So they used the same techniques that everything's verified by. They look at the star and how it red shifts, blue shifts, or how it wobbles. So they went through and they said, okay, we're going to analyze all of the giant planets orbiting stars really close in. So they looked at those really closely, and then they went through and said, okay, out of all of those, about a third of them are not planets.
Really?
Yeah, there was,
are they like Pluto type planets? Is that kind of?
No, it's the binary stars. Say it's you have a giant bright planet and then a much dimmer planet. So if it passes in front, it's still blocking some of the light of the brighter star. So you have a smaller star, a smaller star in front of a larger one.
Right.
If you have a big floodlight, a little LED flashlight, if you pass that in front, it's going to block out more of the floodlight.
And if you're observing it from far away, that would look like dimming.
Yeah, it would look like dimming just a little bit.
Oh, it is dimming.
Yeah, because it actually is. Yeah. And another one of those is failed brown dwarf stars, which are small stars that can't really, can't get the ignition going. They can't start the same way that normal stars do.
Right.
So they're not planets because they are very different process in which they're made and how they're comprised. So they're just these brown dwarfs, these binary stars, and then 13 kind of not quite knowing what's going on there. But in these specific cases, even if a third of them are false positives, that is still way better than any of the other estimates. Right, so the team still said, you know what, a third of them are false positives? Hey, that's still great.
That's great. Yeah, that's great. It is great, isn't it?
Yeah, these are exotic objects. They're not going to be everywhere, so...
They're freaking planets.
Yeah, well, giant planets orbiting really close to a star. Mm-hmm. So, okay, so we thought they were weird. We're picking a few extra up that we, think might be there. That's fine. We're still aiming and saying, hey, all of this stuff is, possible. So what they're doing is they're looking and they're seeing that. Then we can go through and say, okay, start tracking down the list and saying, all right, we need to identify all of these, make sure they are actually what we think they are. And this doesn't affect any of the smaller planets or the longer orbiting planets. So anything with a wider orbit or anything smaller has nothing to do with that. So those are still as accurate as we think they are.
Okay.
So it's just in this one specific case that the study has said, okay, maybe with these exotic, huge, closely orbiting stars, planets, I'm going to keep switching that up. This very specific case, then their estimates are high. But even so, it's still pretty much the best way to identify them.
Yeah. And it's always a process of discovery and then iterating on that discovery and finding out, okay, well, maybe, we got to pull this back a little bit, but
yeah.
Like you said, in the end, it's still a great discovery.
Oh, yeah.
All right, should we move on to mosquitoes?
Yes.
Tell me about this, because I got to tell you, I hate mosquitoes, not quite as much as spiders, though.
No. Well, no. Mosquitoes just make you kind of cringe and itch your arm. You're like, ow.
Oh, yeah.
Arm must itch because the word mosquito has come out.
Yeah. Ugh.
So, mosquitoes in the rain. So, when a raindrop hits a mosquito, that's similar to like a human getting hit by a bus.
Oh, wow. Oh,
mosquito survives.
Wow, that's interesting. Yeah, so you've got a slow-mo water droplet getting dropped on... I love science. Somebody sitting there with a water droplet and harassing mosquitoes just to find out what happens with a slow-mo camera.
Yeah. Well, it was funny, like the whole process of getting this done, they're trying to repeat, rain hitting mosquito. Yeah. So what they started doing is they started sending a spray, hitting droplets down from the third story of a building. They're like, worst game of darts ever.
Right. Oh my gosh, totally.
So then they had to figure out, put a specific spray nozzle on, some water, mist it into a container that has mosquitoes, really fast frame rate of picture, and then you can analyze what's going on. So what's actually happening is that the water droplet doesn't really have time, or it doesn't really transfer any of the momentum to the insect, to the little mosquitoes. So instead of hitting it, they're just kind of moving the mosquito out of the way.
Yeah,
they're not backing into it. They're just kind of sweeping it to the side, like, move.
And it also says here in the video that the hairy surface increases the, sort of the effect of the drop just falling. Wow.
Yes. So it's the way they're made up. I mean, the little hairs are made to kind of help just kind of swoosh it to the side. So it's just kind of dancing around them.
This is actually... In some way, because I hate mosquitoes, this is kind of fun to watch, just these mosquitoes getting the crap knocked out of them.
Water. You're like, whoa.
Take that, stupid mosquito.
Yep. So, the only drawback for them is if they don't get, they're flying, and so the raindrop hits it, and it just kind of moves them to the side, so it interrupts their path of flight.
Yeah.
But if they're hit just right, they're kind of stuck under the water droplet.
Yeah.
Then it can drop them, and it can give them an acceleration of 1 to 300 times Earth's gravity.
Ooh.
So then it depends on if they can get out from underneath the raindrop before they hit the ground. So if they've got to kind of Tai Chi it away from there.
They got to slip out. And it's weird, the way it bounces off of them, it kind of lets them just slip out from underneath it if they could kind of get around it, right?
Yeah. It's one of those things where you're like, yeah, because mosquito, how did they fly in the rain? Because rain is really big.
They get knocked around like crazy, and then they just try to get out of it, right?
Yeah, they just get knocked around, and then they come find us. And then they, try to beat ordinary mosquitoes. But what the science gets out of this, in addition to learning why we can't kill mosquitoes with rain, unfortunately, is designing swarms of tiny robots.
Oh, Heather.
Yes, robots. You can design these tiny things and be like, okay, now we can study the dynamics, on something really small scale. So as we're scaling down, we can be like, okay, this is how they're happy with the rain. So you can kind of look and be like, okay, this is how they're affected. This is what makes them let the rain not smash them, kind of like the insects, like the mosquitoes, just kind of move them to the side. So it's all kind of a study. We may not be down to that small of a robot still, but as we shrink,
right,
to the smaller and smaller, little bugged bugs and such, then
I hate the idea of swarm of tiny robots, but at the same time, learn from nature, because if nature's figured out how to do it, replicate that. Yep.
Well, we've seen a lot of that. We saw a underwater robot, I think a month or two ago, and it was mimicking a jellyfish.
There's also an underwater robot in the movie Terminator.
I see.
All right, well, any other thoughts on that story, Heather?
Oh, Skynet is not allowed in our robots or science.
Right, but if it does happen, you'll hear about it on SciByte. All right, well, let's move on to a very classic 2-Byte news. What? Up, now. The 2-Byte news on SciByte. All right, Heather, what do we have in the 2-Byte news?
Okay. The Johnson Space Center down in Florida is actually going to start tours.
Awesome.
Yes. So starting on Friday, the June 15th, there's going to be a limited number of daily tours available of the control center.
Is it like a hey, come check out what we did when America was awesome tour? Is that kind of what it is?
Yeah. Is just kind of the iconic, room where 152 launches from Apollo to the shuttle, they've all been there. They have a regular admission tour, and then you can pay extra to go into those. I've seen at the Kennedy Space Center in Houston, they had available to tour. Occasionally, you can tour one of those mission control centers, like the old one. They've got the new one that they built for the newer shuttle program, and they had an older one too. So they kind of had two of these. And I remember getting to go through that and just kind of standing in there and being like, this is where the action happened. That is where they stood and said failure is not an option. This is where they pounded their heads trying to figure out this or that. And it was, for that case, it was very awesome for me to be able to do that.
Yeah.
So for anyone that can go see that, if they're interested in space exploration, it's still, you can see it as kind of a downer, like, look how awesome we used to be. But you can also see it as, wow, this is where this and this happened.
Well, yeah.
It's a very tangible feeling of, this is where, you're standing where something happened. You're looking out of the window of where they looked out.
And you see you see all of the resources they had there. You kind of see how real it was. I get it. Yeah.
Yeah, and they're going to have tours down to the vertical, the vehicle assembly building. The really tall building that you can see the shuttle, rolling out of, where they put those together. They've got tours for that occasionally. So all these very iconic places, it gives a very tangible feel to go see them.
Very cool. I would love to do that. I really would love to do that. It's only $25 to get in, but it would cost me a lot more to get there.
Yeah. That's why I was like, Houston was a 2-hour drive away for me, but it was a drive. And I'd go there and I could
do SciByte on the road. A little
SciByte on the road and meet at the Johnson Space Center.
Yeah, totally, right? And then do a SciByte down there. And then I could also do Coda Radio from the road too. No camera needed for that. So
yeah,
something to think about. SciByte, maybe SciByte from Kennedy Space Center in Florida. Probably not.
Yes.
Probably
now all we need is NASA to host us.
Now there you go. That is thinking. Get NASA to pay for it.
There we go.
Man.
They can't afford a shuttle program. They've sure got to be able to afford us.
All that money they're saving.
Yeah, they have negative money. Why not spend a little extra?
Well, Heather, it's no secret that I'm a fan of Jupiter.
Yes.
And I'm also a fan of Jupiter's moons. Yeah, so you got a story in here that might appeal to just that kind of person.
Yes. Jupiter's moon Io is the volcanic moon. So we've always seen, it's all these volcanoes and we're trying to, why is it so active? And we've said in the past, it's because it's so close to Jupiter, it's kind of kneading the planet, sort of like Play-Doh. It's keeping it warm like that.
Yeah.
Except now we've had a map. We've laid out all the different locations of the volcanoes. And that's not matching up to what tidal heating would do. So now we've got this distribution of heat flow that we see based on these volcanoes. And it's not really matching up to the model that we have. And, the depths of it, the locations of it, the main thermal emissions are about 40 degrees east of where we thought they would be.
Huh.
So the heat's coming from, the depths, the shallows. So there's a lot of different places where the heat is coming from and how we're kind of mapping out where the essentially Io lava is.
Wow.
So we're trying to figure out exactly what the process is because obviously our model needs some tweaking now.
I mean, it doesn't have to be completely wrong, but it probably suggests there's some sort of internal.
Yeah, I mean, the tidal heating definitely has something to do with it.
Mm-hmm.
I mean, it's there. We know, we can. The physics says there's this much energy going into it.
Oh, now, interesting. Further, they say here in this article, the study found that that of the known active volcanoes, only about 60% can be accounted for the overall heat that's emitted from Io. So 40% of Io's heat's coming from some sort of mystery source.
Yes, exactly. so not only is our model going to have to be a little bit tweaked to figure out where the extra stuff is coming from, but it makes sense. If there is an extra 40% hanging around, we don't know where it is. We're not quite online for the tidal heating. So there's a lot of things going on. You're like, okay, it's a volcano moon. It's getting needed. It's fine. Well, there's some more going on there. So there's a lot of these models. We've talked about them all the time, from dinosaurs to space. That we have the base model, and we get more data, and we're like,
gotta adjust.
Eraser to this part, eraser to that part. Let's tweak this.
Right.
So it's always that pattern. It's trying to figure out what's going on. And, sometimes you'll get more data and you're like, oh, that's what's answering this question. Mm-hmm. Or sometimes you get more data and you're like, that asks like 5 more questions. So it's interesting. I saw this and I thought it was so cool that there's obviously so much of this heat and so much going on more than what we thought was the only thing there.
Yeah. And it makes you wonder if set down a base right there, use thermal heating.
Yeah.
Get some power generation going, you're good to go. Good to go.
If you have if you don't mind sitting next to a whole bunch of volcanoes.
Oh, right.
Yeah, you're going to get thermal heating, sure.
Yeah.
Right up to the point where the little red light goes flash, flash.
Yeah. Okay.
Bye-bye.
That's a fair point. Well, maybe that won't work. Maybe there's no, that's probably not good.
There's a trade-off there.
Yeah. You know what, Heather? Give and take.
Give
and take. I mean, I wanted to go out and explore the solar system, but apparently you wanted to.
Space is dangerous.
Yeah. Hey, you know what?
Space is dangerous.
It's time to level up a few of our stories from previous. We've got some updates here, don't we?
We do. Oh, neutrinos, how they come and back and like a boomerang. The story keeps coming back.
Yeah, they definitely do, don't they?
Yes. So it was back in October that the researchers at CERN said, oh my gosh, neutrinos travel faster than the speed of light by a tiny little bit, like 0.0025% faster.
Right, and we were like, what? Wow, you were skeptical. And then
I had major skeptical pants on, and it was all over the news. And
Yep. And then I was like, okay, I'm going with you. And then we had stories that said, okay, turns out it was true.
Yeah, then it was, coming back and they said, oh, no, the data's repeating. It wasn't just, this test. It was still doing the same thing. So I kind of backed off the skeptical just a little.
Right, you're like, wow, confirmation. That's incredible.
Yeah, confirmation. That's positive. And then they came back and, said, oh, there's totally a cable here that was loose and can account for those seconds. Yeah.
Isn't that what they said last time? Didn't they blame it on a cable at first last time?
Yes, but now what's happened is they've had 5 different teams independently verify that neutrinos using the same kind of technique at various locations. And at that location saying, all right, 5 different teams say neutrinos travel just under the speed of light.
Huh. Well.
So they've made their, all for the particle detectors at the same location, all said neutrino speed consistent with the speed of light. All of this data has been officially kind of announced, and there's all sorts of teams that are coming together and say, we have verified that those results were bad.
So Einstein was right.
Einstein was right. Now, one thing that I did notice in one of the stories is that the whole team thought this thing besmirched the reputation of the whole collaboration.
Wow. That
in March, 2 of the elected leaders lost a vote of no confidence, and they have resigned their positions.
Wow. Well, I mean, it is kind of a big public embarrassment.
Yeah. Essentially, the teams were like, guys, you published this way too soon.
Yeah.
We needed time to go into the community and, reassess this data, maybe ask another team to look at it before you actually published anything. Something of this magnitude, it's very tempting to publish, to get, the eye to you, the eye to your team, to your location, all that kind of stuff. But you do run the risk of this kind of thing where it's, all the news organizations come together and blast it out, and then it comes back later and you're like, cough, cough,
yeah,
totally wrong.
The thing is it makes such a good headline. Everybody ran with it. So
of course,
it's out there.
Oh, it's, yeah.
But that does mean that we don't have to break our brains over trying to figure out how that works. Yes,
one less thing to break our brains over.
Yeah.
So, there was a famous physicist in all this that said, if it came out that, he's essentially said, if this all pans out and if it's, independently confirmed, I'll eat my shorts. He's like, yeah, not going to happen. He's like, I'll eat my shorts or I'll eat my socks on television or some article of clothing. He's like, I'll eat it on television. Yuck. Go ahead.
Yuck. I would not want to do that. So
yeah.
He doesn't have to. He doesn't have to worry about it.
No, he doesn't have to. It was one of those things that he was so sure
right.
that, this data must not be correct.
Right.
Now, we came back and there was, confirmation and there was some radiation detected. And then there was questions about that. It's gone back and forth. And they did kind of decide that it was this cable. But, the final nail in the coffin is always independent confirmations from various teams and independent sources and various locations. Mm-hmm. Mm-hmm. So no matter whether it's positive or negative, you're ruling it out. You have to wait until, all the I's are dotted and all the T's are crossed. So 2 teams over at this location say one thing and, multiple teams at the same location. So it's all about repeating the data and making sure that everything says the same thing to confirm or deny any original, whatever the original data said, whatever team the claims are saying.
Yeah. Well, Heather, I do declare that if we're not about to do the spacecraft update, I'll eat my shorts. Woo! Boy, good thing the SciByte computer agreed with me. It is time for the spacecraft update. What's going on out there?
So much going on. Oh, so the Shuttle Enterprise has made its last landing. It's on the Intrepid Museum in New York. Now, it's traveling up the river, and the weather wasn't cooperating too much. So it had a sudden microburst of wind, about 35 knots, kind of pushed the barge that it was sitting on, kind of rubbed a panel of the protective layer of the wingtip off.
Oh.
So just a little bit of damage there when the bumpers hit the water, sort of designed to bumper vessels as they go down. But they fixed it. It's up on the ship now. One interesting thing that I saw is the crane that was used to lift it and place it on the ship was the same one that was used to lift the Pan Am.
Out of the river.
Yeah, out of the river.
Yeah.
When they landed on the river.
That's quite the process they took to get that thing home.
Oh my goodness, yes. So they had to fly it in. It made the rounds around the city. I've seen people say, "Oh my gosh, yes, I saw it." So they did that. Then they had to put it on a barge, and it had to go down the river to get to here. Then they had to lift it up on a crane to put it on the deck of the ship. Now they also had to go through and make sure that the decking on the ship was reinforced properly to hold the weight of the Enterprise on these specific wheels in the specific locations. So they had to make some adjustments there. They had to move all these different pieces. It's sad to see these go. It's good to see them being tangible so that maybe they can inspire. But just the process of playing out this deck of cards, saying, "Okay, you go here."
Yeah.
It's a little more complicated than you might think.
It must have taken quite a bit of bureaucratic work to get that whole thing charted out, to get that thing from point A to point B.
Now, like I said, the tiny little wingtip being damaged, I was like, oh no. But they've got it fixed, and they've got it patched up now.
Yeah, that's good. That's good. And that was the Enterprise, too. That never even went up into space.
Nope, that was the one that used to be at the Smithsonian. that was loaded on top of a couple of big Boeings.
So that was some of the roughest duty it's seen.
Well, not quite. This was the shuttle that...
It got up on the back of a 747, right?
Well, they released it, and they used it for the gliding down.
Yeah,
it never had actual engines, but they used it to kind of make sure that the shuttles could come in for a landing like they were supposed to.
Right.
And when, after the Columbia accident, they actually took big foam pieces and fired them at the Enterprise's wings to see if they could replicate what might have happened. So it was kind of used as a testing ground of what was going on and kind of the start of everything.
Right. The prototype.
Yep. Started off with a different name, and then the people rose and said, Enterprise, please. Must be the Enterprise.
All right. Why don't we talk about the Dragon?
Yes. How long can I talk about this, and how long can I stay excited about this? Forever. But it is actually news. It's arrived back in the port of Los Angeles on June 5th. It's now headed to McGregor, Texas for all its unloading, filled with, 1,400 pounds of old equipment. So it's back on land. They're bringing it back to their home station, and then they'll go through it all and, get it all out to where it needs to go.
Right.
Now, there was some of it came out quickly. They had specific cargo that was to be sent back to NASA expedited. So they essentially got it back in. They opened it up, got specific items out, and sent it on to NASA quickly. And then the rest of it kind of is, trucking it on across the U.S. to where it needs to go.
So they passed. Hopefully. They passed NASA's test, and now the contract will begin.
Yep. And so starting in September, hopefully we'll see this happening more often.
Awesome.
Very, very awesome.
All right. Okay, now, but we're not done with the spacecrafts, right?
Oh, no. The NASA Aquarius mission. Yeah. This is measuring ocean salinity. Now, what I found, one of the reasons it just passed its 1 year mark. It's measuring changes in the salinity or salt concentration in the surface of the oceans. Mm-hmm. Now, what triggered me onto this is one of the past SciByte viewer questions sent in.
Right.
The video question from the young class said, "How is the ocean salinity, the salt of the ocean, the same everywhere?"
That was a great question.
Yes, and that's where I brought it up and said, "No, this is how it changes, and this is the data. This is the satellite that brought me, that provided the data for saying, no, these are the different levels of how the salt concentrations are across the oceans."
Awesome.
So it's just passed. It's now 1 year old.
Happy birthday!
Happy birthday!
And they have that cool diagram up on that post.
Yep.
So if you want to find that, links in the show notes to that, you can check that out. All right, why don't we talk a little Mars rover?
Yes. I am speaking as a totally unbiased person that Mars is awesome. Totally unbiased opinion on this.
Right.
The Curiosity rover, it's the next rover coming up, scheduled to launch land on August 5th. Very excited about this, counting down the days now. They had a meeting that said, all right, now we've narrowed down where the landing is going to be. They actually made it they were so spot on, like on target, that they kind of gave themselves a little bit tougher place to land.
Wow, really?
Yeah,
They're like, we're ready for the challenge. We can take it.
Yeah, we're okay. We can do it. So their ultimate goal is this specific mountain. And so they tried to make it where they're going to land a little bit closer to where they want to go.
Oh, so less actual like driving to have to do.
Yeah, a little bit closer to where they want to go. It's a little more rough terrain.
Yeah.
Different elevation, different kind of just slightly different kind of terrain going on. But they're right on target. So I think, you know what, this is going to go fine. We're right on. It's good to land in this location. So it's a little bit tougher, but I'm excited to see it land there.
Yeah. Oh my gosh.
Just in case anyone wonders, might be mentioned in SciByte.
Yeah, that might come up.
Yeah, just maybe.
That is a possibility. All right, well, I think we're all done talking about spacecrafts, Heather. Why don't you step over here in the time machine? And
okay.
All right, here we go.
Here we go.
Oh, watch out. Close the door. Oh, boom. Oh, sorry. That was my elbow. I apologize.
It's okay.
All right,
my ribs
so
survive.
when we go far back, the further back you go, I swear the bumpier it gets. So our first destination is 401 years ago, June 13th, 1611.
Yes, the first publication of some new phenomenon, sunspots.
Sounds like a monster.
Yes. So it was the first publication of these. Somebody was using a technique similar to how various people were watching the Venus transit, last week.
Oh, yeah.
Or
the reflection on like something.
Yeah. So they spotted on there. They think they actually started, looking through the telescope at it, and they decided it was kind of painful. Good idea. So then they switched to projection methods.
So they went blind a few times, then realized.
Then they almost went blind a few times because you never ever look at the sun, especially through binoculars or a telescope or anything like that. And they didn't pay attention to that because they hadn't made the rule yet. But then they finally learned, shining on a piece of paper. And they saw these big, black splotches on the sun. And it was the first time that the phenomenon was published.
Wow. 401 years ago. All right.
Okay.
Any more on that, or should I go to the next one?
Go ahead.
The next one is 260 years ago, June 15th, 1752.
Possibly one of the most famous science experiments. Lightning and kites.
Oh.
And Benjamin Franklin.
Yeah.
Yep. He published his third-person account as a kite experiment. Now, it's not quite as we picture it. He admitted, at first he just mentioned it that he had, witnessed it, that somebody else was going on. And then much later he admitted that he actually performed the experiment himself. Now when it comes down to it, he's actually insulated from the kite. So he wasn't actually holding the wet string when the lightning struck.
Okay.
Because that does slightly more than when the cartoon, little hair goes out and fried and you get a little dust on your face. Yeah, it's a little more serious than that.
Yeah.
In fact, after he published it, some other people tried to repeat the process and were electrocuted. So he had to kind of republish and go, okay, this is how you actually do it the safe way.
So he wasn't very specific the first time through.
No, and this wasn't finding the invention of electricity. It was just saying lightning is made of electricity. So that's what he was doing, is he was proving that lightning was made of electricity, and he was making sure that he was perfectly insulated from this. And this type of a process ended up leading to the invention of the lightning rod.
Right.
I
would think so.
Yep. So the kite experiment was in June. The lightning rod happened in September. So it's kind of a process. He's like, okay, this is electricity. Now we need to make sure that we can kind of redirect it around our houses. This is how to do it.
There you go. The idea that 260 years ago we just figured out that lightning was made of electricity, and now growing up, you learn that is very young. It's just common knowledge. Just something you just completely take for granted. All right, Heather, well, let me retune here and plug this guy in so that way we can look up into the sky this week.
That's right. On Wednesday, June the 13th, Mercury is going to start to become more easily visible after sunset. You can see it low in the west-northwest in the fading twilight. It's one of the ones that's a little more difficult to see. But on Sunday, starting around the 15th to the 17th, Venus and Jupiter are starting to emerge from the east-northeast skies about 45 minutes before sunrise. So we had the Venus transit. Now it's kind of passing. It's starting to appear right before sunrise. Jupiter's going to be over there too. Jupiter is the higher. It's higher to the right of Venus. So Jupiter, the awesome planet, is still on top. It's higher.
Awesome.
And the moon is going to be progressively getting closer to the two. So as the days progress, by Sunday it'll lie just below and to the left of Jupiter at sunrise. So in that area you have Jupiter, the moon, and Venus.
That's going to be a hell of a sky.
Just before sunrise. Those Venus and Jupiter we'll see paired up a lot, and Jupiter is the higher of the two. So look out about 45 minutes before sunrise, and you can see them.
Right on, Heather. Cool. Well, I believe that brings us to the end of today's show.
I think so.
Well, okay. I got a little science for all of you people out there. SciByte is released every single Tuesday. Actually, it's live every single Tuesday. Released on Wednesdays. Yes. Actually, depends if you're Pacific. It actually comes out on Tuesdays too, but I don't really say that very often. But all right, Heather. Well, thanks for a great show.
Awesome.
And I want to encourage everyone to tune in over at jblive.tv Tuesdays at 7:30 p.m. Pacific, or download it Wednesday mornings and check out the show notes for all of Heather's links. All right, everyone. Well, thanks so much for tuning in to this week's episode of SciByte. See you right back here next week.